Hey folks, Mr. Dell here. We are looking at dealing with complex numbers in the form of a plus bi. So give a little bit of a review on that, as well as kind of do some problem sets to show you how you would write them in that form. So this is coming from CPM's Math 2, and this integrated Math 2, and this is section 6.1.2, number 6-22. So it says, write each of the following expressions in the form of a plus bi. So that's a complex number, right? So it's my complex number form. Complex number form is a plus bi. So what do we do? So right now I've got this as 11 minus, I'll look at a first, 11 minus the square root of negative 225. Well, what do we know? So we know that the square root of a negative number, in this case, the square root of negative 1, always produces an I, an imaginary number. So this is an imaginary number, is our I, right? So if I look at the square root over this of negative 25, what that gives me, it's negative, so I know I'm going to get an I out of it, and the square root of 25 is 5, so that becomes a 5i. So what we have is 11 minus 5i. And there is my form now. That's my a plus bi, right? So a being the constant in this form, and then it's minus in this case, so it's a negative 5. My b is negative 5, and then your I is your imaginary part of that number. So there is 11 minus 5i. Okay, so another one. Now we've got a little bit more to do. We've really got two situations because of that plus minus. So I'm going to write them both. I have negative 4 plus the square root of negative 36 all over 2. And then the other one is negative 4 minus the square root of negative 36 all over 2. So these are the two numbers that I'm dealing with that. That really kind of comes from, if you remember what that form comes from, that's the quadratic formula. Comes from the quadratic formula, that look there. That negative b plus or minus b squared minus 4ac all over 2. So let's clean this one up first. So first of all, the square root of a negative number, we know square root of any negative 1 gives you an I. So I know that's going to give me an I, right? So it's an I, and then I know the square root of 36 is 6, so this becomes 6i. So I have negative 4 plus 6i all over 2. Now, it's got to be in this form, so I need to separate. When I say all over 2, what really is happening here, and I'm going to just show you this, is it's divided, the whole thing, each of the numbers are divided by 2. When you're dividing a expression by 2, you can really just divide each separate expression by that denominator. So this now becomes negative 2 plus 3i, because 6 divided by 2 is 3. So there's one of the answers. So we'll do the same thing with this one. This becomes negative 4 over 2 minus, and remember, the square root of negative 36, we know that becomes an I because there's a negative, and then the square root of 36 is 6. And again, all of that's divided by 2. Separate the division. So negative 2 minus 3i is what that one is. So those are the two answers. So we'd say negative 2 plus 3i and negative 2 minus 3i. If you wanted to write them together, you could say negative 2 plus or minus 3i. That also would be correct. Is rewrite them with the plus or minus in between to show the separate. Okay, last one. So what happens with C here? C, it in this form, if we think we've got I need my imaginary number part, right? So I know, again, once again, I know that the square root of negative 1 is I, right? So if that's the case, then I first have to clean that up. So I know, so I would have 8 plus what? Well, I have a negative, so I know I got an I in that. I know there's an I, but the square root of 3 is not a perfect square, right? Square root of 3 is an irrational number, 1.7, such. So we want to leave it exact. So what we really do is just leave that square root of 3 we leave it in the problem itself. So we do have our I, and we did take that out at least. And then there's our A. So here's our A in this case is the 8. Our B in this case is the square root of 3. So that would be that form. So there you go.